Hello, welcome back. We're going to talk about different quotients, or the difference quotient. Sorry, I'm getting tired. But with limits. So we're going to have the same general difference quotient formula that we use, except now it's going to have limits in it. But let's just go ahead and recall the regular basic difference formula. Now, it is a little different with limits, but just as fun. So, let's just go right into an example. So, for this function, f of x equals x squared minus 1. And we are going to try and find limit h going as, okay, so the limit as h approaches 0, we have 3 plus h. Ugh, great. Ignore that. We have 3 plus h minus f of 3 divided by h equals what? So that's what we're trying to find here. So what we need to do is plug in this with our equation here. So limit as h approaches 0, we're just going to plug this in with this here. So we get 3 plus h squared minus 1, and then minus, if we put a 3 in here, we have 3 times 3 equals 9, minus 1, so this would be a minus 8. And then we divide by h. And then once we divide, well, first let's go ahead and off to the side, 3 plus h times 3 plus h equals 9 plus 3h plus 3h plus h squared, or 9 plus 6h plus h squared. So now we have, just gonna keep rewriting the limit so we don't forget it's a limit. 9 plus 6h plus h squared minus 9. Yeah, because we have a minus 1 and then a minus 8 over h. And then, yeah, so then we can go ahead and cross out the minus 9 and the 9, and we are left with 6h plus h squared over h, which equals, and then we can take an h out of this. So 6 plus h times h over h, and then now we have a 6 plus h as our answer. So what we want to know is when h approaches 0, or in this case, we can just set h equal to 0, and we get 6, which is our answer for this one. So it's pretty similar to regular difference quotient stuff. I'd actually maybe argue that it's easier. And for limits, just remember it's approaching 0 or approaching whatever is right here instead of equaling it. But limits are fairly simple besides that. So I'm just going to turn it over and do a bonus example real quick. So for this one, let's rewrite our formula one more time just so we have it. So f of x whoops, that's not our formula. It's okay, I can still salvage it. F of x plus h minus f of x, there we go, divided by h, and then h cannot equal 0. So this equation that we're going to get is 4x minus x squared, and we're going to find the limit as h approaches 0 of f of x of x plus h minus f of x. So we're basically going to do the template formula. Oops, that's not supposed to be an x, that's supposed to be an h. Sorry. Apparently I cannot talk and write. So this is what we're going to find. We're going to go ahead and plug that in here to start with. So we have 4x plus h minus x plus h times x plus h and then, nope, don't put that there. We don't need a squared. We already did the squared. Minus 4x minus x squared. Yeah. Minus 4x minus x squared. With parentheses. So now we've got 4x plus 4h. And then this real quick is x squared plus 2xh plus h squared. So minus x squared minus 2xh minus h squared. And then minus 4x plus x squared, if we distribute this negative here. And then we can cross out some stuff here. So we have a 4x and a minus 4x, so those cross out. And then we have a negative x squared and a positive x squared, so those cancel out, and we're left with 4h minus 2xh minus h squared divided by h. And remember, this is still in limit form. So now we have this, and we can go ahead and just take an h out of the top here. It's 2x minus h divided by h. Cancel the h's out like that, and we're left with just 4 minus 2x minus h. I believe that is the answer. Okay, so thanks for watching. I hope that was helpful.